Bismillahirrahmanirrahim and welcome to this new video. In this video I'm going to analyze another game that is between manager and the worker, and this we will explain with the help of pure and mixed strategies. So many games have the same essential characteristic of the paper rock scissors game that we discussed in the earlier video in terms of having no ordinary Nash equilibrium. It means that games like paper, rock, scissors have no ordinary Nash equilibrium. For example, poker and tennis are also in this category, as are many business situations like manager monitoring employees at work. Before examining these in more detail, we have to explain two different types of strategies. The first type of strategies is known as pure strategy, and the other is called mixed strategies. All the strategies considered so far in previous videos on game theory have been pure strategies rather than mixed strategies. These are strategies, that is, pure strategies are the strategies where a player chooses one action or another with certainty. For example, in the Battle of Sexes game, we have considered the pure strategies of choosing either ballet or boxing for sure. Mixed strategies, on the other hand, are those strategies in which the player randomly selects from several possible actions. So there may be a number of possible courses of action, and the player may randomly choose from those possibilities. A possible mixed strategy in the PRS game, that is paper rock scissors game, would be to flip a coin and then attend the ballot if and only if the coin comes up heads, and that will yield a 50-50 chance of showing up at either event. Although seemingly it may seem bizarre to have players flipping coins to determine how they will play, there are good reasons for studying mixed strategies. The first argument is that some games like PRS, they have no Nash equilibrium in pure strategies. Such games will always have a Nash equilibrium in mixed strategies. Therefore, allowing for mixed strategies will enable us to make predictions in such games where it is impossible to do so otherwise. So, the PRS game doesn't have Nash equilibrium in the ordinary business of life, but it may have Nash equilibrium in mixed type strategies. Although it is beyond the scope of this video to explain how mixed strategies will work, but it is possible that we can have Nash equilibrium using mixed strategies, even in the paper rock scissors game, or in the work, or the manager and employee at work. The second reason is that strategies involving randomization are natural and familiar in certain settings. Students are, for example, familiar with the setting of class. Class time is usually too limited for the professor to examine students on every topic that is taught in class, but it may be sufficient to test students on a subject of topics to induce them to study all the material. So this is a kind of a game. If students knew which topics will be included in the test, then they will only study those topics that are on the exam and not others. Therefore, the professor must choose the topics at random to get the students to study everything. Random strategies are also familiar in sports. For example, the same player sometimes shoots to the right of the net and sometimes to the left on penalty kicks. And in card games, the poker player sometimes folds and sometimes bluffs with similarly poor hand at different times. It can be shown that in case when there is no Nash equilibrium in pure strategies, as is the case of paper rock scissors game, there will always be a Nash equilibrium in mixed strategies. Uh, we can have two different types of payoff metrics. One would be symmetrical and the other would be asymmetric. In order to explain this, we will consider a different situation, a common one in the business. This concerns the monitoring of employees. So there is a manager who may monitor employees at work, and the worker may either work or he or she may shirk on at the workplace. So in a simplified situation, the manager can either monitor or not monitor the worker, while the worker can choose either to work or to shirk. Both players are assumed to choose their strategies simultaneously. If the manager monitors while the worker works, then the manager loses since it costs the manager to monitor, while there is, in this case, no gain because the worker is working and he will be paid for the work performed. If the manager monitors and the worker shirks, then the worker loses because they are caught up and they may lose their job. If the manager does not monitor and the worker works, then the worker loses since they could have taken things easy because the manager was not monitoring. The fourth case may be if the manager does not monitor and the worker shirks, then the manager loses since the firm uh, ends up paying for the work that is not performed. So when the manager is not monitoring and the worker is not working honestly, but he is shirking, in that case, manager is the loser and uh, worker is the winner because in that case he is being paid for the work which is not performed. A simple example of the normal form of this strategy of this game is shown in the following table. Here we can see that if the manager monitors and the worker works, then in that case the manager is losing because it is costly to monitor. In case the manager does not monitor but the worker works, then in that case the worker is loser because he could have taken things easily. In case the manager does monitor but the worker shirks, in that case the worker is the loser because they may lose the job. In case the manager does not monitor and the worker shirks, then in that case the manager is the losing because the worker will be paid for the work not performed. In this initial situation shown in the table, the payoffs are arbitrary in terms of units and are chosen on the basis of simplicity and symmetry. So these are symmetrical payoffs in this table. We may also have asymmetric payoffs. So we'll discuss this in this slide. Just like the paper rock scissors game, it can be seen that there is no equilibrium in pure strategies. For example, if the manager monitors, it is best for the worker to work. But if the worker works, it is best for the manager not to monitor. Note how important it is that the choice of strategies is simultaneous. If one player moves first, the other will play automatically use a strategy to defeat the first player. Again, as with the paper rock scissors game. So there will be no Nash equilibrium in pure strategy. We can now see that in such games the first mover would be at a disadvantage, unlike the game considered earlier. In terms of randomizing strategy, in this case the manager should monitor on a 50-50 chance basis. This choice can be determined by tossing a coin. It may seem strange that business managers should determine strategy in this way, but the essence of randomization is not the method chosen by the randomizing player, but how the player's strategy choice is pursued by the other player. So this is very important. As long as the worker thinks that there is a 50-50 chance of the manager monitoring, This will achieve the desired objective. The same consideration apply to randomizing the worker strategy. Both players need to appear to be unpredictable to the other player. Now we will discuss the asymmetric payoffs. The situation becomes more complicated if the payoffs are not symmetrical as they are in the table in the previous slide. For example, it may cost the worker a lot more if they are caught shirking and lose their job than it costs the manager if the manager needlessly monitors them when they are working. The result may be a payoff matrix like the one in the following table. In this case, these are the payoffs. When the manager monitors and the worker works, the payoff of the manager is 10 while that of the worker is 8. If the manager does not monitor and the worker works, then the payoff the worker is 10 and that of manager is 15. If the manager monitors and the worker uh, chooses to shirk, then in that case payoff of the manager is 5 and that of the worker is 0. And in case the manager does not monitor and the worker shirks, then in that case the payoff of the worker is much higher, that is 15 as compared to 2 of the manager. There is still no Nash equilibrium in this situation. So again, we have to consider a mixed strategy equilibrium. How then do the player randomize given the nature of the playoffs? The above example runs through the lengthy calculation involving in finding all the Nash equilibria of the manager-worker game, those in pure strategies and those in strictly mixed strategies. So it means that there could be a Nash equilibrium if mixed strategies is used, but that involves a very lengthy and tedious calculation. But as far as the pure strategies are concerned, in case of a pure strategy, there is no Nash equilibrium in this manager and work game. So a shortcut to find the Nash equilibrium is strictly mixed strategies is based on the insight that a player will be willing to randomize between the two actions in equilibrium only if he or she gets the same expected payoff from playing either action, or in other words is indifferent between the two actions in equilibrium. So ladies and gentlemen, this is the case of the manager work game in which there is no Nash equilibrium in case of a pure strategy, but there may be Nash equilibrium if mixed strategies are used. Otherwise, one of the actions would provide a higher expected payoff and the player would prefer to play that action with certainty. If you haven't yet subscribed to the channel, kindly do subscribe the channel and don't forget to click on the bell icon so that you can get notification about new videos that I'll upload for you. Thanks for watching this video. Kindly subscribe.